Don't look this way. What a wild sound. I hate... No wastegate, no wastegate. I'm about to head out to TurboSmart, which is actually really close here, oddly enough, to solve a major problem with the 3-rotor. We have too much power. I never thought I would say that. The 3-rotor does, and ultimately the 4-rotor is going to. But what we need to do is solve the fact that in 5th gear, we were doing burnouts. Too much torque in the mid-range needs to be controlled.
So that's the first 45, and that's the current 45. And so this is better than that in every way.
Yes.
Flow, heat handling, obviously size and weight. And this is our motorsport, so this would be for like IndyCar type applications or something like that. So that wastegate's indestructible. If you connect the water ports and run that, you need no airflow through the engine compartment, you need nothing. That gate will last forever.
Wow.
I want to say it goes full open to full closed in like 20 milliseconds or something stupid.
Whoa, that is faster than I was expecting.
Yeah, it's plenty fast.
Yeah.
Yeah. You're going to give it a 5-volt supply, and it's going to give you a 0 to 5 back.
Yep.
To report back to position.
Okay. So position sensor and temp sensor.
And temp sensor.
Yep.
Now, if it's a street car or anything like that, I suggest you connect the water ports. And that's literally just a jacket around the motor. It actually is to protect the magnets. We need to keep that motor within a certain operating temperature parameter, or you could run problems with magnetism and how it works. But
okay, so that's the water jet. Okay,
that's what it's for. Yeah. It's not about wastegate heat or anything else. It's literally electronic protection.
One of my biggest problems is actually, this would solve it 100% of the way, is that my turbo is so efficient it was making too much torque in the mid-band.
Right.
So I needed to tone that area down, but have the high come back up. Like, hey, I've got traction, let's keep going.
You can map that just like you're mapping your fueling.
That's so...
I mean, look at your grid, right?
Yeah.
And you're setting specific targets all over the place. You can do the exact same thing with your boost. Yeah. You can't do that with a pneumatic system. You've taken 2 or 3 steps out of the whole equation with that.
This is my new 1-month-old. This is wastegate. It's different years, you know.
Oh yeah, yeah.
One day is a month for it, you know.
We got so excited after filming that previous piece that we went straight into getting it all configured. Like, that was yesterday, and here we are with it all re-welded, and you watch this insanity.
Well, this guy has a 2.5-inch wastegate, which that's about the same size as me. I'm not gonna lie.
TurboSmart doesn't joke around with about flow. They said that this is the highest flowing gate on the market.
Rob doesn't like the wastegate floater because he's not that much of a man. He's like, oh, I want it to be circling to the exhaust, and I want to be able to drive on my way to my office job, you know?
I hate no wastegate, no wastegate.
No, it is annoying. Rob is an older man, and he needs what he needs. Simple as that.
Aside from the bend that's going to have to come out of here one way or another, everything else we can set up on the bench. You can actually weld that all in on the table, like with it all connected. The downpipe.
Oh, yeah.
So, I mean, I'm telling you what you already well know.
Yeah.
But I meant it more for the camera.
This is the tightest 2.5-inch bend that there is in the world.
Wow. The car is right here, and we can't keep cutting the suspension.
Yeah, you're going to have no shock tower.
Yeah. So you can actually loosen this ring here and rotate this whole assembly, this whole head assembly, any position you want. So right now, we're looking at having the wastegate, comes out right here. It's going to sit in the car something like this, but depending on how we want the wires and the coolant lines, we can rotate this to our heart's content. For you guys watching at home or wherever on the toilet, the wastegate design on here will cause boost creep. Now, this was designed on purpose, so we knew that this could be a problem. A proper wastegate design, if you're trying to truly control it, would be something where it either could go into the wastegate or the turbo. Quite frankly, like Isaiah's design on the 4-rotor, it could go either way and flow out of there. Right now, it has to go into the turbo, back up with back pressure to come kind of choose to also maybe go out this way. It is kind of out of the way.
This wastegate should flow more, so we might be fine.
Yeah.
But if we're not fine, then I just have to make another header. Oh well. It might be one. And that's how a header works, guys. You see?
Nice. Don't look this way. just talking off camera about doing some sort of heat shield. Isaiah has won me over time with ceramic coating, showing me the light that, you know, we can ceramic coat things and knock a lot of the heat off of that. I do want to make some sort of shield for this thing, mostly for the wiring, because we have heat coming from here, heat coming from more so from down here, and that this will cook this over time.
Make it look like I'm on bags, so I gotta adjust my coilovers. You have to lift this up to be able to take it out of this like locking mechanism, and if you don't, it locks again. So you twist it, put it kind of where you want it, make sure it hits in the locking mechanism, and you tighten it back down, and then you should be Gucci. Grab this V-band. This is how you install a downpipe with one hand. There was no way. How the fuck? I have no words. My only thought is to have this go straight up, notch that into there, and then just make it in one piece. Now let's see what Rob thinks. What is your solution?
So we do have shock tower braces right here.
Mm-hmm.
Try to sweep it out as much as possible.
I could sweep. I'm used to it. Is that kind of like what you wanted?
Yeah.
Good luck for whoever has to install this. I can't even get it out right now. That's how you apply some silicone right there. That's proper. This is as big as some like stockings lost. That's the funniest. So the best way to do V-band stuff, especially when you're by yourself, is you put it in there and you hold the V-band together like this. But you gotta hold that shit with your life. If you do that, you can hold the whole thing in place while you put this nut on. Adjust it into place and then tighten. So wastegate. Gotta cut that out, board it out, whatnot, weld it up. Making the end lines, you know, small little things for the wastegates. Joe doesn't think they're interesting, so he hasn't been filming, but I've been doing them.
Right now, I am working on wiring up the electronic part of the wastegate. You'll see here, this is thicker wire that's meant for higher, current, so power and ground, and that is actually the control for the wastegate position. So you see it right there, it's open up a little bit. You don't want to power this up. You actually have to calibrate it and figure out what's full, what's closed. You could overdrive it and do bad things. So this is a very advanced setup still. It's not a plug and it is plug and play if you're in my spot, honestly, because there's tons of stuff you have to do. But these two are the power, 0 to 12 volts. Then you've got two more that are, you got a sensor, signal and ground, and then the other two are a position sensor. So it's funny because this is almost identical to drive-by-wire. Drive-by-wire is the same thing. Drive-by-wire has a motor, 100% throttle, 0% throttle. It has a sensor. Is it at 100% throttle or 0% throttle? And then not a temperature sensor, but you get the idea. Very, very similar to that concept. What's important to me is that I am using the larger, the medium-sized DT connector. This one will probably go on the harness. This one will go on this end. We need to make sure that none of this can melt, can get near the exhaust. So this is gonna be a little bit of a challenge because it's gonna sit back of the turbo here. The downpipe's right here, so I might clock this. Here's the two coolant ports that we talked about earlier. That'll keep this cold, but I do wanna think about the wiring. That's the most fragile part, I think. It can handle, I think, 250 degrees sustained boost up above that, but I'll probably wrap this whole thing in some sort of insulation as well, because we've gotten so far with the 3-rotor. Anyway, with all of Isaiah's part all figured out now, it's time for my part, which is this right here. The wiring is utterly insane because it's very new. As soon as we saw it, he just had it all in there, plugged in, and I was like, oh, that looks good. We forgot to film this part. So here we are.
But I mean, look how big this thing is. This is like, you know, the size of my head.
Pretty
This is meant for some power. Like, I've never seen a hole this big.
I'm gonna be taking this on and off and watching the position of this piece here. So really, all the fancy stuff that we're doing is simply to open and close this valve up and down. That's all of this work is meant to just do that at a very fast and very powerful speed. So say, for example, if we were to go anti-lag this right now and shut it, the anti-lag is not going to bounce that valve, which will bounce any pneumatic valve on the market. So anti-lag would be even more nasty. I've got 6 wires to get to here. I don't want them melting with the exhaust nearby. We've got the 2 coolant lines that Isaiah just did that look beautiful. We've got a driver, as you guys will see here. I've got some more wires that I'm actually going to take off of my drive-by wire setup that I don't have yet, but I have the wire for it. I'm going to turn that into drive-by wastegating.
But the cool thing we're going to do about this, and one of the main reasons why we're getting this, is so instead of traction control, we're doing wastegate control.
Yes.
So instead of boost by gear, we're going to be able to control boost by each gear through this thing, which is insane.
Yeah, so that's a really good point, is that what you're seeing here is absolute prototype stuff. And so if I have any issues with it, bear in mind that this is truly a first one-off. You know, I'm getting help directly from the engineers making it, because this is almost too soon for even them, but they're being kind and they want to see this happen. So the goal is, instead of cutting ignition or cutting fuel in other people's cases, we're going to be cutting boost. That way the turbo still is spooling, still at peak performance, peak energy, everything's ready to go, there's no lag. This thing can pull back based on wheel speed, you know, wheel slip and all of that sort of stuff. So we can map out this wastegate more than just simply, oh, the air says we need this. We just tell it what to do, and that is probably the most insane thing, and a little overwhelming. What do you tell it to do?
I want to show my badass coolant lines that Joel doesn't think much of. But they're still cool nonetheless. They do coolant, you know.
We have something super, super exciting to show you, and as you saw earlier in the video with the whole wastegate setup, you need something to drive it. At first glance is already well polished. It's from Fuel Tech. It's the 3rd one in the world. The only other 2 that are in the world are on Anderson's cars, the owner of Fuel Tech's. So I'm the 3rd person to have this. And with that, I'm making something really experimental. Now, Joel stopped, and the reason we're filming this section is he asked me, why am I doing Barbie hair on this? And the reason why is it's kind of a makeshift Faraday cage. It's a makeshift grounding cable, because these are all high current, relatively high current runs in a straight line. And anytime you have high current that's passing through and making a lot of changes, our crake ankle sensor runs near this, and we're going to move it out of the way for that reason, but they run in the same line. When you have 2 wires next to each other, the same line, and one's changing current and up and down with voltage, you create basically a electrical interference. So this is a grounding cable. If this were to fall over and go onto the wiring harness for the ECU or whatever the case may be, at least I'm trying to do a little bit more to prevent that. Hardcore 12 volts in and ground in, and then we have signal line out. And these are still beefy wires, because this side controls it like a relay, but it doesn't control it like a relay on off. It controls it like a relay in the sense of 0 to 12 volts. So the position on that wastegate is controlled similar to throttle bodies, and it needs to be able to force itself against up to 200 psi of air pressure. That's why you need some beefy wiring. Let's see, hide all of that right in there. This one's gonna lock it all in with adhesive. Compensate cow. Cow. Pussy cow.
Pussy cow.
Okay, I'm gonna be honest with you guys. I don't know Portuguese, but that's how hot off the press this is that they're showing me a beta version that they're testing back in Brazil, and there are a handful of guys running this. But thankfully they sent me screenshots of what I need to click, because some of these words actually make sense, you know. RPM, tabella, tabia, day. See, it makes sense. It makes sense. TPS. See, I basically can read Portuguese. This is a crazy moment for us right now. I've got my test harness made, semi-production, but I've learned some things as I go. We've got the driver for this sitting here ready to go, and purposely not connecting the 2 main things up together. So what I'm gonna do is turn the power on for the car, make sure I get 12 volts and what else I need on this, and then plug these 2 up and see what happens. But holy crap. So I went and made sure we have the temperature sensor working, the position sensor working, I'm not sure. We're gonna go ahead and calibrate the sensor and see what happens. Okay, so I'm gonna press calibrate. What a wild sound. Oh, it is ready to party now. That is so sick. It's all controlling itself. And I want to point out, this thing can react within about 20 microseconds or 20 milliseconds. It's insane. So what it was doing there was checking its position. It was automatically calibrating up and down because it has enough power to basically rip itself through the bottom of the wastegate. So this is something that you have to be very careful with. I didn't want to reverse polarity. I didn't want any of that. So now, I'm gonna test one very basic feature. So you wanna go in the car and see, we'll just give it gas. Under 30%, it should be right there. Position it to 100% open.
Okay, that seems more open.
Yeah. Basically, we just set the default value. So if I set it to 0, wow.
That's so cool.
Yeah.
Such a weird sound.
Yeah, what a wild sound. We can actually do gear and engine RPM, elapsed time, time-based after launch, after a validated launch, when it knows that the car has successfully launched properly. Engine RPM, reference speed, we've got all these different options. This is something that we have to film, is you know what this normally means if you've ever worked on a wastegate. Taking the top off means that you're gonna rip the bolt holes open because there's a massive amount of springs inside of it and you are going to trash it or need some sort of vise. Even with TurboSmart's other ones, that was the case. But with the electronic wastegate, there's no, look at this, there's no springs. It's so counterintuitive to me because every single one of these, including blow-off valves, all have springs and diaphragms. This unit does not. What we're gonna do right now is we're actually gonna manually override the wastegate position because I don't think that was 100%, but this is, this is all new tech. So I'm gonna have the wastegate try and open all the way, and you're actually supposed to have the valve seat on this. The valve seat is the thing that actually sits inside of here, and so that way it goes fully open and actually fully closed. Once Isaiah gets the exhaust back on, now that I'm out of his way, we will put the valve seat part on and then recalibrate it so it doesn't crush down. Okay. There's the magic behind it all. In here, that little thing right there is a manual override. There's a little 5mm Allen wrench, I think, and we'll be able to actually override the position electronically controlled. So I want to show you this outside the car just so you can see what's going on. There's the little 5mm hex head right there, and I'm going to go ahead and turn it this way, and you can hear the motors, right? But inside there, you can see the valve lifting. Slow, to me, means high torque. It's geared in a way that the pressure underneath here is not going to push it up. You can see that you just have to fight that. We're going to put it in, have the valve seat here, so when we go this way, as it comes down, you need the valve seat there to go, okay, it has now landed on the seal, and you're at absolute 0, closed. And now we're going to go all the way up and see what that is too. So we'll get this mounted in. Be a little tricky. It is said that it should be 0.6 to 0.8 volts for completely open. And so once I go right to here, yeah, there's 0.6. And then I'm gonna say, hey, this is 100% open. There's me. You can see that closing.
Need a faster wrist, sir?
Yeah. Once you put the valve seat in and close it up, I'll tighten it as much as tight can go. Set that number, and then you know what we'll do is we'll remember these numbers, and then we'll click Calibrate Auto and see what the ECU finds to be the range. Now that we've got it mounted in, we'll get a nice shot for you guys of looking down into it with it completely closed. But what I'm doing is I'm just feeling it. As soon as it binds up, that's closed. Looks like it stopped moving right there. That position is 4.4 volts. So we're going to calibrate that to 0. We currently had 4.6, but there was no seat valve, a valve seat in there, so it thought it could go further. So we're going to go ahead and calibrate 100% to that number. We'll go ahead and open it up all the way. That is maxed out 0.7. So we'll calibrate 100% to that. So that's our voltage range from 0 to 100%. We're going to let it auto calibrate and see what it feels is physically the hardest and softest. We'll let Fuel Tech do the job. So I'm going to take this off, auto calibrate, and you can actually watch. You guys get to watch the inside the gate. Delphi does not open it as wide as we did. Closed, it was identical. It went from that 0.6 to 1.4. So even TurboSmart says, hey, don't go 100% duty cycle in this case. So I'll let it do this, and we'll watch to see what it does with boost or control or whatever the case may be. But that is proper. Calibration is successful. And I think we're ready to dyno a digital wastegate.